My name is Reece Sainsbury from CQ University, and this presentation is about Reuleaux's mechanical elements. Before I explain each of these elements, it is important that the background information of the person responsible for these elements is known. Franz Reuleaux, considered the father of kinematics, was a German mechanical engineer who lived from 1829 to 1905. He developed the fundamental concepts of modern mechanisms known as kinematics during the late 19th century and expressed these through 6 mechanical elements. Reuleaux's 6 mechanical elements of machine design are used throughout modern day products and mechanisms. Reuleaux's 6 mechanical elements are levers and cranks, wheels and gears, cams, screws, things to transmit tension or compression, and finally, things that transmit intermittent motion. Levers are one of the most basic machines of science and are used commonly for humans to gain a mechanical advantage. Levers are grouped by 3 classes depending on the placement of the pivot point in relation to the effort and load. A Class 1 lever has a pivot point between the effort and the load, for example a hammer. A Class 2 lever has a load placed between the pivot point and the effort, for example a wheelbarrow. A Class 3 lever has the effort exerted between the pivot point and the load, for example a set of tweezers. Cranks are a mechanical mechanism which transfers an input force or motion to a particular output location. They are used to convert circular motion into reciprocating motion or vice versa. Cranks have the ability to change the direction of force, change the length of the motion of the force, or split the motion and force over several parts. Cranks are seen in places such as bicycles and winches. Wheels and gears are rotary mechanisms which transfer or change an input rotational motion and force to an output motion or force in the form of rotation or reciprocal motion. Both wheels and gears are usually incorporated with an axle in modern day mechanisms. Wheels work by removing the frictional force between the wheel and the surface, creating a rolling inclined plane. When teeth are cut into the wheel, a gear is made. A gear fixed to an axle where the input force is being applied, input axle, is known as a driver gear. The gear where the output force is going, fixed to an output axle, is called the driven gear. Several gears connected and working together is called a gear train. 2 gears meshing will spin in the opposite direction. Putting a gear in between the driver gear and the driven gear will make both spin in the same direction, allowing the input and output motion to occur in the same direction. The way the gear trains are configured depends on the desired output. Gear ratios are determined by dividing the number of driven teeth by the number of driver teeth, and are altered in order for mechanisms to serve a particular purpose. Cams are like gears, however they are smooth and not consistently round in shape. Cams are commonly used in conjunction with crank-slider mechanisms in order to convert rotary input motion into a desired reciprocating or oscillating output motion. For example, cams along with a crank-slider mechanism are used in internal combustion engines in order to open and close valves. The rotational motion of the camshaft is driven by the crankshaft, which is driven by the reciprocal motion of the pistons within the engine cylinders. Screws convert rotational motion to linear motion and torque to linear force, for example a builder's screw and a drill. Screws consist of either a solid or hollow shaft and a thread. With the rotation of the screw shaft relative to the stationary threads, the screw will move along its axis. With things to transmit tension or compression, we must understand what these terms mean. Tension and compression are the terms which describe the way forces are acting. Tension is when several forces act in opposite directions, and compression is when several forces act towards each other. Chains and belts are ways which tension and compression are transferred. For example, a chain on a bicycle or a motorbike transmits tension forces through a chain from the drive sprocket to the driven sprocket. Intermittent motion is a motion which starts and stops in intervals. Ratchet mechanisms are the oldest form of mechanism to create intermittent motion. A ratchet mechanism is used to prevent an axle from turning in a certain direction using a wheel with curved teeth and a pawl. As the wheel turns in one direction, the pull falls in between each of the teeth. The wheel is prevented from turning the other way, or the opposite direction, by the way the pull is shaped in conjunction with the shape of the teeth on the wheel. During this video, I have described each of Reuleaux's 6 mechanical elements. You should have an understanding of how these elements exist and operate, and also how they appear in modern-day mechanisms and products. Thank you for watching.